In this video, I will go over inclusion and exclusion principle, a very powerful, useful principle in probability. So the inclusion and exclusion principle is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now, you might be wondering, why do we have to subtract the probability of A and B? I will explain that in this video. First, the conjunction or, in some textbook, they don't write the word or, they write capital U. So what is this U stands for? This U stands for union. So union means or, A or B. And then the N, they use an upside down U. So this upside down U stands for intersection. What is or mean in statistics? So A or B means A or B or both. So let me give you a Venn diagram. So this is a sample space. I have two events. This is A, and then this is B, and then the intersection is both. So this is both, this is A, and then this is B. So A or B means I want A, I want B, I also want the both. And then what about A and B? A and B is what A and B share in common. So we draw another Venn diagram. So we have A, and then we have B. So A and B, I want what they share in common, which is the intersection. So that is the upside down U. The A or B is this letter U that stands for union. Now, let me explain this. Why do we need to subtract A and B? So if you look at the first Venn diagram, you have A plus B and the intersection, right? You have this A, you have this B, you also need the intersection. But if you look at the inclusion and exclusion principle, which it has another name called addition rule, you see there is a minus the probability of A and B. Why? So here is why. So let me draw a picture really quick. So I am going to draw an Venn diagram to explain this. So we have a sample space. All right, so I will start with event A. So this is event A, right? I am going to shade the entire region. So this is event A. Okay, so A. And then for event B, I will use another color. So event B, let's pick another color. Let's pick red. So this is event B. And then I want A plus B, right? So I want the entire circle of A and then the entire circle of B. Now, tell me, what's the problem right here? Do you see a problem? Do you see a problem right here? The problem is I have orange and I have red. So it looks like if you look at the intersection, I already count the intersection one time, right? I count the intersection use orange. And then I put the red on top of orange, which means I count the intersection twice. Let's go over this again. I have an orange circle for A. I fill up the whole circle. And then I need to fill up the entire circle of B using red. So when I fill up the orange, I already fill up the A and B. So the intersection was already filled up, right? So it looks like you have orange for A and the intersection. And then when you fill the circle of B, you put red on top of A, right? You put red on top of orange, which means you count the intersection twice. So when you count the intersection twice, you have to take it out. So you have to subtract the intersection one time. Let's do this again. I have one circle. I fill the entire circle. And then I have another circle, right? I need to fill out this circle. So when I do this, look, when I do this, I count the intersection twice. So that's why you have A or B equals to the red circle plus the white circle, and then subtract the intersection one time. So that's why you have to minus, and that's why we call this inclusion and exclusion. You include both circles first, and then you exclude the intersection one time. So that's explain the reason of using a minus A and B. All right, so let's do a quick example. So we have another example, a quick example right there. A local cell phone repair store offered the following facts. 65% of the repairs were due to external damage, 50% were due to water, and 37% for both. So let's do it. So probability So probability of external, I will just use E, so that is 0.65. Probability of water, that is 0.52, and then both, so that will be external and water, right? That is equals to 0.37. So what I am looking for is, we receive a request, what is the probability that the repair is about external or water? So that is about the probability of external or W. So A or B, that equals to the probability of A plus the probability of B, it's not really B, plus the probability of W minus both, right? Which is E and W. So you plug it in, you have 0.65 plus 0.52 and then minus 0.37. I use 65 and 52 for a reason. If you don't do the subtraction, you have 0.65 plus 0.52, right? That is already more than 1. So that is 1.17. This cannot be a correct answer. Probability cannot be greater than 1. So therefore, you have to subtract 0.17. You subtract the intersection one time. What do you get? You get a 0.8. So that is your answer. And then I have one more problem. Are these two events independent? So you have to give me a proof. To prove that two events are independent, you have to prove that A and B is equals to probability of A times probability of B. So what is E and W? That is equals to 0.37, right? Equals to 0.65 times 0.52. My question is, are they equal? If they are equal, then they are independent. Otherwise, they are not independent. So 0.65 times 0.52, that is equals to 0.338. The other side is 0.37. They are not equal. That means they are not independent. Not independent means they are dependent. So that's how you answer this question. So that will be the end of this video. If you think my instruction is helpful, please like, subscribe, and share. I appreciate your help really much. I see you all in the next lesson. Signing out.